Today's show is sponsored by Ravello. Having a hard time hiring engineers? Ravello lets you sidestep the competitive U.S. talent market by helping you hire skilled remote engineers in Latin America. They provide full-time senior engineers with 5+ years of experience who are embedded in your team like a normal hire. Ravello is an end-to-end solution that handles sourcing, vetting, hiring, payroll, and compliance. They also don't force you to pay for things you don't want, like a project manager. You can interview any engineer before deciding. All engineers are proficient in English and have high time zone alignment with US-based teams. You don't have that painful 24-hour turnaround where you have a question for an engineer who is on the other side of the world. Check out Ravello today. Go to ravello.com/cloudcast. Check it out. That's REVELO.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And let's get this right out of the way. It is a Sunday show, and it is Aaron. What is going on? Well, we're taking a break from Sunday perspectives this week. Brian and I have decided, based on a couple different things, to give him a break from a Sunday show this week. And we might be doing it intermittently in the future as well. So why? First, we have a huge backlog of shows right now, and that is thanks to you, our awesome listeners. And so we're going to burn through that backlog for a little bit. And then second, conferences are coming back. Longtime listeners know Brian and I used to attend a lot of shows as media sponsors for the podcast. We would record live shows at events, Google Next, LinuxCon, DockerCon, All Things Open. Those are just some of them I can think of off the top of my head. And well, we're not moving back to that model just yet. And it turns out, by the way, our live rig is dead anyway. This episode is first in a new format to bring awareness to certain events that might interest you, mixed with a guest and a topic related to that event. And so for that, let's dig right into that. Our first event we wanted to highlight is SLO Conference, the Service Level Objectives Conference. This is an all-virtual conference event taking place May 9th to the 12th, and you can register online for free at sloconf.com. Well, what would you expect at something like that? Well, there's on-demand talks, there's hands-on labs, which, by the way, as an aside, I'm registered for and plan to do. I love doing hands-on labs at events. I'm a visual and tactile learner versus auditory, and so anytime I can do a hands-on lab, I try to do those. There's going to be job postings and networking opportunities. There's an SLO Conf Slack channel. And there's lots of topics, everything from intro to SLOs to talks on the future of SLOs. So if you're new to this area, maybe it's something you register for and you attend just a couple of the intro sessions as well, which is, again, something is a good place to just jump right in. And with that, it's time to go to our interview. Coming up right after the break, we have Brian Singer talking about service level objectives, what they are, why they matter, and how to use SLOs to focus on innovation versus technical debt.
Today's show is sponsored by Datadog, a scalable, full-stack monitoring platform. Datadog synthetic monitoring enables you to detect front-end errors and performance errors by analyzing user sessions and receiving actionable alerts. API tests help you detect and debug user-facing issues in critical endpoints and applications. Build and deploy self-maintaining browser tests to simulate user journeys from global locations. Start proactively monitoring your user experience today with a free 14-day trial of Datadog by visiting datadog.com/frontend-cloudcast. That's datadog.com/frontend-cloudcast.
Still using SSH keys, RDP logins, and database credentials? It's time to access your infrastructure like it's no longer 1999. StrongDM is the only modern infrastructure access platform. It creates a seamless, secure, and observable air gap between your staff and the critical infrastructure that powers your company. Instantly revoke access to every database, Kubernetes cluster, or server with a click. Automatically log every query SSH, and kube control command to know who did what, when, and where across your stack. Eliminate credentials from end-user workflows to deploy access that's zero trust and least privilege by default. Trusted by your peers at Peloton, SoFi, Yext, and Chime, StrongDM is the only way to deploy secure access controls in a way folks love to use. But who believes an ad? Check it out for yourself with a no BS demo. Sign up at www.strongdm.com/get-a-demo. And we're back. And this week on the show, as mentioned previously, we're going to talk about SLOs, or service level objectives. And in order to do that, we have brought Brian Singer, co-founder and chief product officer at Noble9. And Brian, first of all, give everyone a brief introduction.
Hi, everyone. Thanks for having me on, Aaron. So like Aaron mentioned, I'm the co-founder and chief product officer at Noble9, where I'm basically responsible for our engineering organization and developing our SLO platform. And before that, I've been in startups and enterprise software pretty much my whole career.
Yeah, and also too, by the way, if everyone wants more information on this, above and beyond SLOconf, we did a show with Alex from Noble9. It was show, I want to say 502. So it was a little over a year ago. So just so everyone knows that if you want another perspective as well, there's always that show to go back and listen to in the library. But let's, Brian, let's start at the start. If someone isn't familiar with SLOs, or service level objectives, how do you define them and why do they matter?
Sure. So SLOs essentially are a framework to figure out how reliable or unreliable the digital services that I'm responsible for should be. So, for example, I might say, I want this API to respond within 500 milliseconds, 99% of the time, right? So it's how, what it should be doing, and then how frequently it should do that thing. And so we have a lot of great data about our services, our products, our user journeys, and that data doesn't necessarily have the context. It tells you a lot about what's actually happening right now, how many errors a service has, or what the response time is of an API, but it doesn't have the context for how it should operate with respect to what other dependencies might be expecting, what our customers might be expecting, what the business needs. So SLOs provide all that context on top of all of the data that we have about our software. And maybe a follow-up question, or actually two follow-up questions real quick. How is this different from, I'm very familiar with SLAs, service level agreements. And so that's one part of the question. And the second part of this, is this also almost like an approach of embracing a little bit of imperfection? Because I feel like, this is maybe a more SRE focused topic, but this is all about, there is going to be downtime, or there is going to be a certain amount of instability. So how do you capitalize that and use that to an advantage? Is that proper way to think about something like this? Yeah, absolutely. So I mentioned it's how much reliability or unreliability I'm willing to accept in my services, and that how much failure I'm willing to accept is a really important concept. And while SLOs grew out of the SRE organization at Google, they are actually pretty broadly applicable outside of organizations that are strictly doing sort of the SRE, by the SRE book. And so there are concepts that I think are just, as an engineer, they're sort of universally applicable to kind of any sort of engineering we're doing. And the example that I like to use is, if I'm actually like building a car, the thing that makes it potentially really, really expensive is the materials that I'm using to build it, and the tolerances that I'm using to build the parts, to machine the parts, for example. And as we machine parts in the physical world to smaller and smaller tolerances, we make them more and more perfect. the cost to do that goes way, way up exponentially quickly. And the same thing is true for operations teams and software engineers. The more perfect we try to make our software, the more expensive it gets, because we have to spend more time testing and we have to spend more time making sure that the changes that we make to the systems aren't going to be disruptive. And that's important to a point. It's important to a point where customers really care about it, right? We don't want to make changes that necessarily are going to make our customers, whether they're internal or external, really upset. But there is a set of diminishing returns when it comes to that. And it actually is typically, we're actually allowed to be far more unreliable than people think. And so it's really about just giving us more margin for error, more room to make mistakes, which lets us move faster as engineers.
And Brian, it's an interesting concept because I feel like it reminds me of the early days of cloud and public cloud, and as the services were emerging, there would be outages, pretty decent size outages at times. And, people didn't necessarily give up on public cloud, right? Like it was a little bit of like, how much downtime can you have? And of course they want to minimize that over time. And all the big public cloud providers have gotten better and better at it. But we go back to the early days, and even today, like every once in a great while, something does go down. And it's almost like a little bit of, you don't want to be perfect, but also I really like that idea of like, okay, it's almost like a budget. How much time and resources do you want to put into this? And how can you manage this to a certain window of unreliability, but that the customers still stay happy? Is that, the correct way? Okay.
Absolutely. And it's sort of, I think implicit in what you said is not all outages are created equal. And not everything, the definition of is it down is actually very dependent on what you as a customer are trying to do. Just to tie it back to the SLAs, you mentioned, how is it different than SLAs? Well, in how we define an SLO typically is pretty similar to an SLA. Like, over the course of 30 days, we want 99% uptime. The problem with most SLAs is that they're very coarse, and they're also typically tied to financial penalties. So because of that, they're sandbagged. So they're not a reflection of user happiness. They're a reflection of, what essentially two lawyers were able to negotiate in terms of financial remedies. And as engineers, I would argue we should be a lot more concerned with what is going to keep our users happy. And that's going to be, that's going to depend on how they're using our service. In the case of a cloud provider, if the control plane for launching an EC2 instance goes down for 10 minutes, like that's not great, but I would argue that's not as bad as, for example, maybe a running VM just getting randomly shut down by AWS. So I would argue probably the SLO for random VM gets shut down should be a lot tighter than the SLO for control plane for launching an instance is unavailable for some amount of time. And so when you start to dig into, okay, how are people using the different aspects of this product? What really matters? What really matters to the users? You start to get some pretty wildly different expectations in terms of uptime and reliability and whatnot, even for one product, right? It's not just about, can I hit the website or not? It's about, what am I trying to do on that website, and is that functionality available to me?
Okay. That's a fantastic point. And I'll take that even one step further. This creation of those initial SLOs. You mentioned earlier this came out of Google and SRE organization at Google specifically, and a lot of times I think SREs are kind of managing these or taking the first crack at them, if you will. But how do you make that connection or correlation between the metrics that matter and correlating them to business KPIs? Like, how do you know, like, this is the metric you need to track that actually impacts the customer or impacts the business? Is that because I would imagine an SRE can't do that in a vacuum.
Exactly. So the great thing about SLOs is pretty much anybody can, sort of walk through the workshop and define them for a service that they use. It doesn't have to be an engineer, even in a lot of cases, even, sales or customer service or product managers have a pretty good sense for what the customer's expectation is. I can say, for example, with Noble 9, right, we have an expectation for when you log in, how long it takes for the first page to load that you see. Or when you open a chart, like how long does it take for that chart to render? And as a product manager, like using the product, I can say like, well, I kind of expect that chart to show up probably within a second, right? Maybe 2 seconds, 99% of the time. But I'm willing to accept that maybe 1 out of 100 times I load that chart, it's going to take 5 seconds. But so you start to hone in on that. And so if you start to look at what am I trying to do? How am I using it? You can define the expectation for how it should behave and the risks associated with it failing. And then from there, you can go back and say, okay, how do I get the data to represent this, right? Rather than starting from, okay, I have all this data. Let's find the right signal. You start from, okay, let me define the risk to the service. Let me think about how customers are using it and how it should operate. And then I'll go find the data. And typically, usually you'll have it. And if you don't, it gives you a really good roadmap for sort of what sort of instrumentation you might need to add.
And is this something as well, like, I would imagine this is something you start with a first pass, and then there is fine tuning over time. Is this something that is kind of automated fine tuning, or is this recommendations come back of like, hey, you might want to look at this? Or is this more of like, that's where almost like a business analyst has to put on their hat and kind of go, okay, this is where we are, but this is where we want to go. Like, tell me about the journey over time.
Yeah. So the most important part of it is to get started. And that's what I try to tell people. Once you start seeing that data come in, it can either confirm sort of hypothesis that you might have, or it can actually disrupt your mental model for how you think things should be operating. I can't tell you how many services like we've defined SLOs for, and then we realize that we're failing at them really, really badly. But nobody seems to mind. We don't, customers aren't calling complaining. If you ask customers, hey, is this fast enough for you? They say, yeah. And then it's like, oh, okay, well, actually, we can relax this quite a bit. We don't need to be nearly as stringent maybe in some of the policies that we have in place as we thought we needed to be. And that's a great feeling to have as an engineer. Hey, maybe instead of, needing to be next to a pager within 5 minutes of a computer, it'll be okay if we're, 15 minutes away or 20 minutes away from a computer. So that's one of the outcomes. The other outcome that you can get is you turn an SLO on, and you're never burning any error budget. But then you have outages that you didn't predict. So at that point, you can say, okay, maybe actually we need to tighten the threshold, right? Instead of 200 milliseconds being a request that would burn error budget, we'll make it 100. And that's a more accurate reflection of what the business requirement is. So it really, like you said, it is a process of fine tuning, but the data that you get at the very outset can be really helpful in figuring out which direction to go.
And I would imagine as somebody in charge of product, it also can help with the concept of keeping the lights on versus innovation, right? There's always the concept of technical debt. And do I go work on technical debt, or do I go do innovation? Yep. Startups are notorious for innovation. You need to build up just this mound of technical debt over time. And you don't go address the technical debt until like it starts to impact sales or, there's something not like somebody, it's become
customers start churning,
problem.
But
right.
Yeah.
Right.
But by that point it's too late.
And so does this help with this?
Yeah. Yeah. SLOs are very impactful when it comes to, helping prioritize in our roadmap. For one thing, if a service is operating normally and we have good SLOs on it, and it isn't running out of error budget every month, then it's a pretty good indication that we don't need to worry too much about the architecture of that service right now. Whereas, plenty of times we've had services where we are running out of error budget, or, we make a change, we add this is really common, right? You add a feature, and all of a sudden that has some ripple effects downstream in terms of the reliability that you didn't expect. Like maybe you're calling an API more frequently than you were before, and that API, the architecture behind that API can't handle the load that you're now putting on it, which you didn't predict. You would see that really, really clearly in a error budget burn down chart, and you could then make the decision, hey, we actually need to go refactor the service that's sitting behind this API. And that's a really, really common thing to do. The other place where it's common is like if you're burning error budget, right, you can actually make some decisions about how you back off some of those requests. So it's not always about just re-architecture and, okay, let's go pay down that technical debt, but maybe we're going to prioritize certain requests over others in order to sort of defend the error budget that we have available. But those decisions, without SLOs, you're kind of making them in a vacuum. You might see error rates go up, but it's very hard to say, is this impactful? Is this something that I need to be worried about? Is this something that should cause me to sort of upset my engineering roadmap? And I've never seen anything like SLOs that gives you the clear signal that, yes, this is something you should do, or this is something you shouldn't.
Yeah. And I will say this as, past startup experiences, it's always been interesting to kind of be in those roadmap discussions, and new products are, coming out, or new innovation or new features are coming out. And there's always this, okay, do we need to go work on the technical debt? And everyone's like, not yet. Okay. It kind of feels like, the data just isn't there a lot of times of like, which one do you go do? So everyone kind of favors go doing the fun stuff.
Yeah. But it's not, it's so true, but it's not just in startups, right? In large distributed engineering organizations, this is a huge problem every day, where you might have external dependencies that are core to your service, and you need to make the argument that, hey, they need to go improve their service, right? They're not, whatever they're doing isn't meeting the standards that you need, but you don't have the data necessarily to go make that argument to say, hey, why don't you staff a project to do this, tech debt burn down, which is not like the most exciting thing in the world. Nobody ever went to a CEO and said, hey, our next quarter is going to be all tech debt. And it's right. So, but now you're kind of armed with the data to go have that conversation and to prioritize those things. And it can be a huge quality of life improvement for the engineers. And I think, as we all know, like recruiting and staffing and retaining engineers is so hard in today's environment that these are the sorts of things organizations are trying to do to make themselves great places to work.
Yeah, it makes perfect sense. And so, Brian, I'll close out with this. Let's kind of dig maybe a little deeper into the technical implementation side just a little bit. So how does something like this work? Is this like the SRE organization connecting this up to existing systems? Is this new tooling and plumbing? Like in my head, I'm like, okay, do you connect it up to a GitOps workflow, for instance? Is this like SLOs-as-Code? Like, tell everyone a little bit about how we get from the beginning to, the burn downs, if you will.
Yeah. All of the above. So we built Noble 9 specifically to drop into an existing environment and work with the data that organizations are already collecting about their services. So there's no big, massive instrumentation lift. It's typically maybe an observability engineer or some SREs hooking Noble 9 up to the existing data sources, whether that's like Prometheus, or something like it, and then the teams then defining their SLOs. They can do that in a sort of graphical user interface based wizard, or like you said, as code as YAML configuration that then gets checked in. The nice thing about the approach is that you can get started with more of a sort of user driven approach, and then as you go to production with SLOs, there's something that can be versioned and reviewed and templatized. And so, we see actually organizations investing in a lot of automation now around their SLOs, because while the fine tuning is very service specific, there's some baseline sort of goodness that you can get across an entire API surface pretty quickly. And so it's exciting to see where different customers of ours have gone with just the baseline platform that we've given them. And then obviously that's given us some ideas about where we should be taking the product.
Nice. And follow up to that, is there like automation triggers or conditional things that happens in it? Or is this more of like it's pulling in all the data and it's providing a dashboard?
So it does provide a dashboard, but I'd say no platform like ours would be complete without some alerting. So within Noble 9, you can create alerts based on how much error budget you have remaining or how quickly you're burning it, and then you can hook that up to your existing sort of incident management or paging systems like PagerDuty, for example. And then you have a really nice way to get alerted, not just if like an error rate goes up, but if something really impactful is happening to a dependency or to a customer.
Awesome. Fantastic. Thank you for that, Brian. So I'm going to close out there actually. So I'm going to end with a thank you to both Noble 9 and SLOconf for having us as a media sponsor. If you're listening to this and you're interested in learning more, first of all, SLOconf, depending on when you're listening to this, is coming up. So go ahead and register. It is free. It is all virtual. Go ahead and go out to the webpage. It is in the link in the show notes. So you'll be able to just click on that and you can go check it out. In addition to that, as always, thank you everyone for listening this week. And really, if you can, tell others about the show and certainly leave a review wherever you get your podcasts as well. So on behalf of Brian, who wasn't able to make it this week, thank you again for your time, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.